Hi everyone, welcome back to my YouTube channel. So it has been a while since I have uploaded a video due to personal problems, and we are sort of limited here in the weather. It's quite cold here today, so I'm going to now move on and start uploading videos again. So what I'm going to do here is I started a model lathe back in the summertime, converting it with an electric motor on it. So basically what I'm going to do is I'm going to start this project again. So I done an introduction video, I think it must be about 5 months ago now, converting it to, away from the pedal to a motor. There was actually a motor put on it in the past, however there was no variable speeds, etc. So what I'm going to do is I'm going to start from the very beginning. I have video clips all pre-recorded from the summertime, so if you notice the sun out, that's why. It's currently creeping into December here now. So yeah, we'll see how it goes, and I hope you enjoy this little video because it'll be quite interesting. So I'm going to do it in separate parts. So there's going to be obviously an introduction. This is going to be part 1. Part 2 is probably going to be mounting the motor. So first things first, I have to describe where I'm taking the motor from, the control circuit, and yeah, everything, the cables, etc. So also, when I take the motor out of this unit, this exercise machine, as you will see in the video demonstrations here, I will be making my own brackets, adjustable brackets, and working out ways how to make it mechanically movable, sort of to alter the gears, if that makes sense, because as far as I mind there was 9 electronic speeds, and I'm looking to increase the number of speeds from, we'll say 1 to whatever, 27. So basically I want to have 3 mechanical gears too, that I can move the motor between different sizes of V-pulleys. So we're going to move on here now and see how it goes. Okay everyone, so what I'm going to do here now is I'm going to take this piece of equipment, which is a vibrating machine for exercising, apart. Before that I'm going to demonstrate what it actually does. So let me see if I know how to work it. So put her up to maximum speed. Oh, it's so nice. Okay, so we're 9 speeds on this. I'm using this digital panel here. So what I'm going to do is I'm going to remove the motor, the electrical circuit, the motor controller, which is obviously a variable voltage regulator. So I'm going to remove that. I'm going to remove the panel controlling it, and obviously the input, and we're going to remove the motor, the output, and we're going to put it onto the lathe. So the motor on this is a DC motor, so it's actually got high current or high torque, which high current motor, so high current DC motor. So what I'm going to do is I'm going to strip this piece of equipment down, get a look at the shaft size in the motor, and fit it to the lathe. So when it's fitted to the lathe, I also want to have 3 manual gears, and I also want to have I will have 9 electronic speeds. So that gives you 27 gears, which is good for a lathe. So you want as much variability as possible. So from low spindle speed to high spindle speed, chuck speed. So this will also control the self-drive on the axis that slides the chuck in and out. Or sorry, not the chuck, the base to the chuck. So again, I'm going to demonstrate this wee machine going one more time. So it's actually quite nice. Zippers, right. So I'll put her up to full whack. Okay, that's it at full whack. So it's working anyway. So what I'm going to do here now is I'm going to take it apart on the ground, take it in, mount it to the lathe on a sort of like a auto adjusting, so there'll be no locks. I'll be able to push the motor in to flip between 3 manual gears. There will be a V pulley on the motor itself, which is in this at the minute. I have never seen it. I'm hoping that it will be perfect size, the shaft size and stuff. Obviously the torque needs to be right, the RPM needs to be right. It's setting 1 here on the digital panel. It should be running quite slow, I hope. Setting 9, so 9 times setting 1. So we're going to take it apart now. The only way we can do this is trial and error. So what I'm going to do is I'm going to take the motor out of this, put it on the lathe, make the brackets up, all using stainless steel. Then, when this is completed, I'm going to use this panel for the digital control. I'm going to make a nice stainless panel here and all, fabricate it up as I do, and see how it goes. And hopefully it turns out a nice wee project. So, that's it. Okay, we're taking this apart here now. Okay, everyone. Okay, everyone, so I can see the motor here now. This is not very big, but I can assure you the torque will be quite high in this wee motor. Spindle torque. The shaft's probably about, I'm hoping to be about 8 mil wide. It's open to me here now. There we go. So here we have the motor. Here now, so we have a weight that gives you the vibration. So I will be removing the weight block here off the shaft. The shaft looks to be about, maybe actually be 6 mil, so I might need to support the shaft after I put the pulley on it. And so what I'm going to do here now is I'm going to take the circuit, or sorry, the control panel out of this. Here we have the controller. So this is a DC voltage controller. AC side, so the hot side and the cold side here. And this is the input from the panel. I have it plugged out currently. So what I'm going to do now is I'm going to, well, I need to take a motor off this, but this bracket. We have the controller out. We're going to remove the input here, so we're going to remove this panel and the cables and take it from there. Right, so the Allen keys. So we're removing the panel here. Cable. We will use this too. Don't need that. So next step now is the motor. So don't need this weight. It creates the vibration, momentum, or the motion. So we can chuck this away too. We also don't need this big bulky, I'm going to say it, big stupid looking bracket. So I'm going to remove this too, off the motor. Or sorry, I remove the motor out of the bracket. It's the rear side, of course. 14 mil. So there we have it. Finished. We don't need this piece of rubber either. So on this motor we have the cable shaft. We also have a ferrite clamp or a filter for removing any interference coming from this DC motor that may interfere with the the switching circuit or other external sensitive circuitry. So this is the motor. The spindle size is about 8 mil, so it's not that small. I'll be able to support it. I will support the motor. I will make a plate up for this, and we will make it adjustable to the lathe. Hopefully it's got enough torque. But at the end of the day, the lathe that I'm using is just a model lathe. So I'm basically setting this lathe up to turn down shafts at 3 mil, 5 mil wide. But I'm sure that we'll do more. I'm sure this wee motor will provide enough torque. Obviously it's using this exercise machine for vibrating. But we'll see how it goes. So that's it. Next step now, we have the panel. We have the variable voltage regulator, controller. We have the motor. We have this panel. The last thing we need now is a couple of more cables. So these cables are buried within here. Getting them out might be a tricky task. So we'll take the switch too. The main switch. So here we have the power cable. We will use this too. Make use of everything. Okay everyone, so the last thing we need off this is a cable that runs from the board to the input, which is the panel. So removing these dome head screws. The reason I'm using vice grips and not the Allen key is because the screws are chowed, somebody has gouged them. With them out cheap Allen keys that comes with these machines. So in order to get this cable out, we have to slide off this piece of rubber. There we go. Fan-dabba-dee-doo. Finished. So this is the cable that will control the lathe in the end up. So what I can do now is I can throw all this other rubbish out. Where do we see? So we have the control panel, we have the controller, and we have the motor. The motor is about the size of a large mug, a very large mug. So what we're going to do now is we're going to throw all this rubbish out, the scrap. Bolts and all have been thrown out because I'll be replacing everything to stainless from here on to the lathe. And we don't need this. That's just a nice chrome coating. That's not stainless. I don't think anyway. No, it's not. It's just my steel. So I'm going to chuck that out. Chuck everything out. Put this together and get it going again now. Off the machine obviously. And take it from there. Okay everyone, so we have these components lying here now beside the lathe, the miniature lathe, model lathe. So next step now is finding out a way to attach this DC motor. So I have already been looking at it here. So here we have the main pulleys driving the chuck. So what do we see? What I want to do here is I want to make use of this 3-stage pulley for 3 different gears. Well, there will be the electronic gears on this panel, so I have already demonstrated that in action with the vibrating machine. So what I'm going to do is I'm going to make a nice panel here. I'm using stainless steel, and I will actually use this space, this control panel, for the lathe itself. So next step now is making a bracket itself for this motor. It's going to be all stainless. So what I'm going to do is I'm going to make a mounting point for the motor about approximately here. Or I could go to the back. What do we see? I could also go to the back of the lathe and turn the motor this direction. So I can easily reverse the direction of this motor by switching the polarity, so it's not an issue to, reversing the motor on the lathe. So what I'm going to do is I'm going to make this motor adjustable on sort of like a spring-loaded tensioner with no lock. So when I let go of the motor itself, it comes out to its full tension. The reason being is because these 3 pulleys is different sizes, and when the motor's released from the smaller pulley, you also want it to hold the tension on the bigger one, or vice versa, both directions. So I'll explain that in more detail. So if I have the motor here now and it's on the bigger belt, you also want the motor to automatically adjust out in order to tighten this for the smaller pulley. So hopefully that makes sense. And also the middle one. So that's it. So what I'm going to do here now is I'm going to demonstrate making this plate for the motor. So we're going to go outside till sunlight. Okay everyone, so we have the motor outside here. You can see the shaft size is quite small, so we will get into that detail, fitting the pulley after we make the brackets. So we need to make a bracket for this, and this is an aluminium face alloy. So what I'm going to do is I'm going to make a nice stainless bracket for this, and also I'm going to make a stainless surround for the control panel. After this we will move on to the pulley and the belts and the tensioner. But first I'm going to just show how a demonstration how I'm going to cut this out. So this face on this paper is drew out on this using this motor. So what I'm going to do here now is I'm going to trim this right out, this piece of paper, and I'm going to use it as a template for this sheet stainless. And take it from there. So the stainless I'm using is 3mm thick, 304 grade brush stainless. So here we go. So you can see here I have added in 2 lugs, this point and this point. So one point is going to be the hinging point, and the other point is going to be the points where the preloaded tension will be on the motor, pushing the motor out to keep the belts tight. So here we go. Joys of not having a laser machine. Second lug. Okay, so there we go. Next step now is taping it to the stainless here, 3mm plate, and cutting around it with the grinder. But the way I'm going to do this here is I'm going to mark it with a sharp Stanley knife instead on the brush. So you can see there, if I mark it here, you can see the fine line on the stainless. Okay everyone, so taping this template to the stainless. So first thing I'm going to do here is going to bore the holes. Then I will mark it with a sharp edge, scribe it. So you can see here from this packaging tape that it's see-through. So it's nice and flat now and ready to rock. Drill the holes. Okay everyone, so we have about 10 holes bored in the centre of this plate to make one big hole. So what I'm going to do now is I'm going to ream each hole together in order to remove this bit of stainless in the middle. That will allow the shaft of the motor to come through. So here we go. There we go. So now I just have to ream it up to a nice 30mm diameter hole. Nearly there. Okay, so we have this hole filed out now to a nice, we're gonna just double check the size of it, so I think it's near 30 mil by A. Okay, so it's 31.5. We have it filed out now, nice and neat. We match the motor. So, as you can see here now, we have the motor and the plate ready to be bolted. I've already started drilling these holes. These holes are going to be drilled to 6.8 mil for an 8 mil tap. And I should also point out here, below this motor, below this plate sort of, even on the face, there is a fan inside this motor here, which obviously draws in cool air and blows out the hot air. So it is important not to block these holes off completely. So what I'm going to do once this plate is finished, I'm going to bore about, many? 2, 3, 4, 5, 6, 7, 8 holes right round the face of this plate to let the motor draw in air, cold air. Otherwise the motor would overheat and it would be very stupid to do that. So we're now going to tap these holes, or bore these holes out to 6.8, and then we will do the mounting holes for the pivot action and the tensioner, and then we will cut the plate out nice and neat. Okay everyone, so before I start tapping the holes in this plate for the motor, I'm going to demonstrate how I actually am going to make a pivot point for this. So if you're probably wondering where I'm coming up with a design of this, so basically as I'm working here, I'm just coming out making things up in my head. So I'm designing it in my head, if I could say. So what I'm going to do here is we have a piece of 16mm bar and we have 2 bushings. These bushings is also 16mm inside. A grub screw can be placed in here, however I won't be using a grub screw at all. So what I'll be doing is I'll be leaving the motor adjustable over the width of that 3-stage pulley. So the 3mm plate will be sitting in here, welded with a TIG welder at both sides. The reason I'm using 2 bushings is to sturdy the plate, so the plate's always perpendicular to the bar, so you know what I mean. So when I'm sliding it side to side, there's no play in it, it's nice and tight. So what I'm going to do here now is at this lug here, there will be a 16mm hole also, and that stainless bushing will be welded here, and at the opposite side 2 bushings. So basically this plate will run on the bar side to side. And what I'm going to do now is we're going to finish off tapping these holes and cut the plate out, and then we'll move on to that stage then. Okay, so just marking this hole here for the pivoting point, where the bushings will be welded at both sides. So there we go. I'm also going to place an 8mm hole up here for an actuator or a spring. So basically I will just measure the centre of this round lug, which is 40mm, so here we go. And also down, I'm going to bring the hole down 15 just. So we have a nice balanced looking hole, the hole in the right place even. There we go. So an 8mm hole, 6.8mm hole, and a 16mm hole. Okay, so I'm doing the 16mm hole here now for the pivoting point. I don't have a 16mm drill. Even if I did have a 16mm drill, it'd be very hard to bore because stainless is quite difficult and tough. So here we go now with carbide burr. Change the cutter here. So there we go, perfect. It doesn't need to be perfect. The hole sides can be a wee bit bigger because I will be placing the bushing at both sides of us, as so, like that, and there will be another one at this side. So when they're welded on, I'll be able to slide a plate side to side, nice and easy. So it's better that hole being a wee bit bigger than 16mm. So that's it. Okay, so I'm tapping the holes here now for the motor. 8mm M8, 1.25. So the hole was bored was 6.8mm. So there we have a nice thread there now for the motor. So next one, bit of cutting oil. And basically keeping the tap nice and straight. Three done and one to go. So the reason I'm tapping them here is because I don't want nuts on the back of this plate. Doesn't need to be adjusted or slackened at any time. Once the motor's on, it's on for good. So when this final hole is tapped here, we will move on to cutting the plate out to match this template. That's it. Blow the threads off before bringing the tap through again. Usually helps. So there we go, plate finished, ready to be cut out. Okay everyone, so I'm about to cut this plate out now. All the work is done to it. The tapped holes, the boring holes. I have to turn the mask on here because it's going to steam up. I turned it off. Okay, so here we are. So basically I have to cut round the plate, right round it. What I'm going to do is take pictures of doing this rather than recording it because it'll be a slow process. When it comes to filing it using the carbide, filing it using the files, manual files on my die grinder there, I will do video demonstration of that. So if you want to see pictures of cutting it out, please see the end of the whole video. Okay, so just going to demonstrate what I've done here. So to this plate I have cut it out obviously, and it is now filed right up to the line that I scribed down with the Stanley knife or Stanley blade or scalpel even. So basically what I done here is the template that I made, I scribed the line around it, so it's near enough. Ignore these marks with a permanent marker here, they're not being used now. So what I've done here is now I went round the whole bracket and filed it up to the nice line. So as you can see, it's nice and neat, matching the template. Next step now is well, the tapped holes, the hole for the shock absorber and the hole for the pivoting action for the 16mm shaft to go through and the bushings to be welded on either side. Next step now is the motor. So what I've done here is I've took the motor apart to find the best way, the easiest way even, the easiest option to locate the holes that need to be bored on the plate. So what do we see when I remove this brush assembly here? So I'm just taking this off for handiness. Okay, there we go. So now what I can do is I can put a couple of bolts, not four, two will do rightly. So if I put 2 bolts on here, so now you can see that my plate meshes up to the flange of the motor nice and accurately. There will be a bushing here and one on the other side, like so, welded on with a TIG welder, and basically that will turn on the shaft. So this is the motor plate, the mount housing, the mount flange. So what I'm going to do now is I'm going to basically put nice wee scribe lines around this with a scalpel. So basically I would just be going round like this, the reason I don't use permanent marker here is because permanent marker will burn and fade away when I'm going to drill it, the heat. So if I do it this way, it means the scribe line will always be there. A piece of metal, anything fine, will mark the stainless. So that's 2 done. There's 8 holes. So you want these holes clear, obviously, let the motor cool the motor down and the fan's going on the motor. So, well, there's actually no fan on this motor, but the whoosh of the rotor itself. So, get the heat out, let the heat escape. So what I have to do now is remove the flange, the motor flange, and bore these holes. So what I'm going to do, I might put one single hole in the middle of all oval holes. You can see them there, I hope, if I bring them up close. So you see the marks I put on it there now. So I either will cut them out nice and neat like that, or I might just go bigger. 8 big holes, or 8 holes in the centre of the oval shapes. Well, they will be sort of looking like ovals. So here we go. Okay, so I have the motor bolt together here now. So it's back in working order, I hope. So next step now is boring these holes, 8 holes. So what I'm going to do here, I'm not going to slot them, but I'm just going to bore concentric holes straight in the middle of them. So what do we see? About there. Okay, so we have the holes now bored in about halfway. I can bore them straight through now with a wee bit of oil, bit of cotton oil. Okay, so we're done there now. Next step is boring these holes out to maybe about 8mm. I'm not going to turn them into the oval shape, elongate them. I'm just going to leave them as they are, but bore them out to 8mm. Okay, so we have this plate screwed to the bench here now. Hopefully this 8mm drill bit's okay. I had to sharpen it there. Wee bit blunt sort of. Drill's dodgy. The drill's done, Milwaukee drill. So that's a Generation 2 FPD Milwaukee drill. The control side of it, trigger, look. Done. Then you put too much pressure on it, it cuts out at low speed. Sometimes you have to pull the battery on now to get it working, but it's bored there now with a wee bit of struggle. So countersunk next. To get the drill to go in reverse, so you have to take a battery out and put it back in. They're not a very good drill, so they're not. The other Milwaukee drills was good, apart from this. Don't like it at all, drill. Okay, other side. Okay, so that's the plate finished. Taking the motor apart was a huge advantage for marking these holes. So next step now is setting it on the motor. So you can see here that the holes are not blocked on the motor now. So that's good. I'm going to give us a wee sand now and clean up. Look at the pictures at the end for more detail. Okay, so to wrap this video up, a few images now of the design process. So this is the little exercise, or the vibrating machine being stripped. The paper template ready to be used at this stage also. So this was attached to the stainless to be scribed around. This is drilling the, what is it, the 20mm, I think it was approximately 20mm hole in the centre for the motor to go through. So the aluminium case. This lamb was cleaned up using the die grinder. The holes for the mounting of the motor at this stage to be ready to be tapped out. So all these were 6.8mm holes for an M8 tap. This is a stainless plate ready to be tidied up and grinded into the scribed line. So at this stage it's still quite rough around the edges there as seen. There. So quite jaggedy yet. This is the plate nearly finished and all grinded edges and filed. Countersunk holes too, as you can see there, them big mounting holes. So this is the motor and the brush assembly that needed to be removed to figure out where the venting holes were needed to be placed on the plate for the motor. This is the plate completely finished with the vents, 8 wee holes. So this is the final clip off the pulley here that will be attached to the motor. This will come in part 2. I hope you enjoyed, everyone. Okay everyone, that is it. All finished until probably I will upload another video, part 2 of this project in about 2 to 3 weeks, and I will show exactly how I'm going to mount the motor to the lathe with the brackets that you have already seen currently made there. I will also go through mounting the panel of the exercise machine. I will also, maybe I might finish the whole lathe in part 2, I don't know yet. I might move on to part 3 and do the final touches such as painting it and building the stand with casters, just to make it more movable, and yeah, that's it. So hopefully when the sunny weather comes back I will we'll put up better projects and my unique projects again. Until then, I'm not sure if I'm going to do this because I can't imagine me going anywhere with my project. You take it out in this, like you can hear there in the introduction or even this clip, the wind noise is a lot of wind today. So that's it. I hope you enjoyed this little video. Part 1, part 2 is coming in 2 to 4 weeks. Thank you for watching everyone. Bye bye.